Okay, so the next example that I wanted to look at is a simple parallel circuit with 6 ohms, 10 ohms, 20 ohms, and 50 ohms, much like the series one that we did earlier. So I'm going to draw it out. And we have a 6-volt battery attached to several resistors. One's 10 ohms. One's 6 ohms. One's 10 ohms. One's 20 ohms, and one's 50 ohms. Now, this is a parallel circuit, as you can see, because there's multiple paths for charges to flow. It doesn't have to flow through only one path to get back to the battery. Okay, so I can find the total resistance in parallel by using the equation 1 over R total is equal to 1 over R1 plus 1 over R2, etc., etc. So I have 1 over the total resistance is equal to 1/6 plus 1/10 plus 1 over 20 plus 1 over 50. So it looks like my common denominator here is going to be 300. So 6 into 300 would be 50. 10 into 300 would be 30. 20 into 200 would be 15. Or 300, I'm sorry. And then 50 into 300 would be 6. So if we add those together, 50 plus 30 is 80, plus 15 is 95, 95 and 6 is 101 over 300. Now you have to keep in mind that the total resistance is the reciprocal of this. So our total is going to be 300 over 101, which is approximately 3 ohms. We'll just go with that. It's 3 points. Just under 3 ohms. Okay, now we can do our chart. So we'll do R, I, V, and P. Now since they're in parallel with the battery directly, they all get the same voltage as the battery. So they're all going to get 6 volts here. So I have 6 volts, 6 volts, 6 volts, 6 volts for the 4 resistors, which were 6 ohms, 10 ohms, 20 ohms, and 50 ohms. Okay, so now what I can do is to find the current. Okay, and to find the current, all I do is divide the voltage by the resistance. So obviously this is going to be 1 amp. So it's going to be 0.6 amps. This is going to be 0.3 amps. And this will be like 0.09, or 0.11, I'm sorry, 0.11 amps. Then we can multiply through to get the power, so this would be 6 watts. This would be 3.6 watts, 1.8 watts, and 0.66 watts. So this is an example of a simple parallel circuit.